Here is a scenario that happens to every team at least once. Saturday afternoon. Your app is down. Users cannot log in. Transactions are failing. You find out not from a dashboard, not from an alert, but from a tweet, or a support ticket, or your CEO forwarding a complaint. By the time you see it, the incident is 45 minutes old. This is not a technology problem. It is a monitoring problem. The data was there. The failure was happening. But nobody was watching. Azure Monitor exists to make sure this never happens to you again. It is the central observability platform for everything running in Azure. Metrics, logs, traces, alerts all in one place. By the end of this video, you will know exactly how to set it up, so that you find the problems before your users do. Azure Monitor collects two fundamentally different types of data. Metrics are numbers over time. CPU is at 78%. Memory is at 4.2 gigabytes. There were 1,200 requests in the last minute. Metrics are lightweight, collected every minute by default, and perfect for dashboards and alerts. You can answer, is my system healthy right now? Logs are records of things that happened. User ID 4821 got a 500 error at 14 hours 32 minutes and 7 seconds. Request to /checkout took 8,400 milliseconds. Exception, null reference exception in order service line 142. Logs tell you why something went wrong, not just that it did. Here is the practical rule. Metrics tell you something is wrong. Logs tell you what went wrong. You need both. Use metrics to catch the problem. Use logs to diagnose it. The best thing about Azure Monitor is what it does without any configuration. The moment you create an Azure resource, a VM, a database, an app service, Azure Monitor starts collecting platform metrics automatically. CPU, memory, network in, network out, disk ops. No agent. No SDK. No setup. Just there. The activity log is equally automatic. Every single Azure control plane operation is recorded. Who created that storage account? Logged. Who deleted the firewall rule at 2 a.m.? Logged. Who changed the app service plan before the outage? Logged. This is your audit trail and your first stop during every incident. But here is the part most teams miss. Resource logs, the detailed operational data, are not on by default. You need to enable diagnostic settings for each resource. Go to your resource, click Diagnostic Settings, choose where to send the logs. Send them to a log analytics workspace. That is where the real investigation happens. A log analytics workspace is where all your logs come together. Every resource you configure sends its logs here. App service, SQL database, Key Vault, VMs, Kubernetes, all in one place. You can even connect multiple subscriptions to a single workspace. And then you query. This is where most people get surprised. The query language is called KQL, Kusto Query Language. It is not SQL. It is more like a pipeline. You take a table, filter it, aggregate it, render it. But here is what nobody tells you. You do not need to learn all of KQL to be useful. The four operators you use 90% of the time. Where, to filter rows. Project, to choose columns. Summarize, to aggregate. Order by, to sort. That is enough to answer most questions during an incident. Find all errors in the last hour. Sorted by count. Done. Let me show you 4 KQL queries that will cover most of what you need. Query 1, find all Azure deletions in the last hour. Azure activity, pipe where operation name value contains delete. Who deleted something? You will know in 2 seconds. Query 2. Find your top failing API endpoints. App requests, pipe or success is false. Pipe summarize count by name. Pipe order by count descending. Which endpoint has the most errors? Instantly visible. Query 3. Latency trend over time. App requests, pipe summarize average duration ms by 5-minute buckets of time generated. Add pipe render time chart and you get a graph. No dashboarding tool needed. Now pay attention here, this one matters for every incident. Always filter by time first. Without a time filter, you are querying potentially days of data. Start every query with, where time generated is greater than ago 1 hour. Your queries will return in seconds instead of minutes. Azure Monitor covers your infrastructure. Application Insights covers your application. It is an application performance monitoring tool (APM) built into Azure. For web apps on App Service, you enable it with one toggle. No SDK changes. No redeployment. Auto instrumentation handles everything. What you get immediately. Every HTTP request URL, status code, duration, user. Every dependency call, database queries, external API calls, latency. Every unhandled exception with full stack trace. User sessions, page views, custom business events. But here is the feature I use in every production incident. Application Map. It draws a visual graph of all your services and how they connect. Each node shows the error rate and average latency. You can see in 10 seconds which service in your chain is the problem. And live metrics. Real-time streaming telemetry. Updated every second. When something is actively failing, this is where you watch. Monitoring without alerts is just a pretty dashboard nobody watches. Alerts are what make monitoring actionable. Metric alerts are the simplest. CPU above 85% for 5 minutes, fire an alert. Available memory below 500 megabytes, fire an alert. Request latency above 2 seconds, fire an alert. These catch infrastructure problems before they become outages. Log alerts are more powerful. Write a KQL query. If the result crosses a threshold, alert fires. Any 500 error in the last 5 minutes, alert. Failed login attempts above 100 per minute, alert. Any log message containing the word out of memory exception, alert. And this is the part that impresses every team I show it to. Application Insights has smart detection. Machine learning trained on your traffic baseline. It automatically detects anomalies, unusual failure rates, abnormal response times, unexpected dependency failures. Zero configuration. Azure learns you're normal and tells you when something is not normal. An alert without an action is just noise in a log nobody reads. Action groups define what happens when an alert fires. Simple notifications: email the on-call engineer, send an SMS, push to the Azure app. For critical alerts, severity 0, you can even trigger a voice call. Nobody sleeps through a phone call. But here is where it gets powerful. Actions can run code. An alert fires, and automatically. An Azure function runs a remediation script. A Logic app creates a ServiceNow ticket. A webhook notifies your PagerDuty on-call rotation. A runbook in Azure Automation restarts the affected service. The pattern I recommend for every production system. Severity 0 and 1, page the on-call via PagerDuty webhook, wake someone up. Severity 2, email the team and create a ticket. Severity 3 and 4, log to a Slack channel for next morning review. Match the severity to the action. Not every alert deserves a 3 a.m. phone call. But the right ones absolutely do. Let me bring it all together. Azure Monitor collects metrics from every Azure resource automatically. No setup required. It starts the moment you create anything. Log Analytics gives you a single place to query all your logs. Enable diagnostic settings on your resources. Send logs to your workspace. Query with KQL. For operators cover 90% of what you need. Application Insights gives you deep visibility inside your application. Requests, dependencies, exceptions, user journeys. Enable auto-instrumentation on app service, done in one click. Application Map shows you which service in the chain is failing. Alerts tell you before your users do. Metric alerts for infrastructure thresholds. Log alerts for application-level errors. Smart detection for anomalies you didn't know to look for. Action groups make alerts actionable. Right person. Right channel. Right severity. Automated remediation where possible. The goal is simple. You should never find out about a production problem from a tweet. You should find out from an alert before anyone else notices. This is part 22 of the Azure series. If you are serious about becoming a cloud engineer, subscribe and keep going. Next up, Azure DevOps pipelines and how to deploy code without touching a server.